Alright, so here's the video for 3A and B and then problem 4. The first part here for A, we need to calculate the area of the circle Z, which means I need to find the diameter of this circle. The first thing I'm going to do here, I know the inscribed angle, the arc measure here is 40, which means this inscribed angle V needs to be 20 because the inscribed angle that creates the arc measure is always half of it. And so we have 20 and then that creates a 40. And then this is going to become trigonometry to figure out that diameter. And the trigonometry or the trig function we need to use is cosine because we have this 9 centimeters here that's adjacent to our angle and we're looking for hypotenuse here. And so adjacent hypotenuse is going to be cosine. So to get this problem going, we need to do the cosine of 20 and we're going to set that equal to adjacent over hypotenuse, which is going to be 9 over x. And then cross multiply here to solve for x. 1 times 9 gives me 9. The cosine of 20 times x gives me cosine of 20 times x. We're going to divide both sides here by the cosine of 20 so that we get x by itself, and that x is going to be our diameter. So we divide both sides here by cosine of 20. 9 divided by the cosine of 20 is going to give me 9 so x, or the diameter, is going to be 9.58 after I round it, which means the radius here is your diameter. So we just found out that diameter is 9.58 just through trigonometry, and then radius is always half of the diameter, so we take 9.58 and we divide it by 2 to get 4.79 as a radius. And then area for circles is always pi times the radius squared, which is going to give me pi times 4.79 squared. And then there's 2 ways you could write this as an answer if you wanted to. 4.79 squared gives me 22.94 pi, so you could write it like that. Or if you wanted to, you could say 22.94 times pi also is the same thing as 72.07 if you wanted to write it as just a decimal. And both of these are centimeters squared, depending on how you write it, but it's both centimeters squared because it's an area. And so right there would be your answer for part A. Again, to recap, we're using cosine, and specifically we're using the cosine of 20 because the arc measure here is 40, so inscribed angle is 20, and cosine because 9 is adjacent and we're looking for hypotenuse, and that hypotenuse is our diameter. So we find diameter, we cut it in half to find radius, and we use that radius to find area. We'll move on to part B here. I'm going to clear my ink so I have room to work. And what we'll see here is we're looking for the length of xv. So we're looking for the arc length of xv, and I wish it was as easy to say, well, that's 40 degrees, so that's 140 degrees, but we're actually looking for the length of it. And to do that, we're going to need to figure out the circumference of the circle and then multiply it by the portion of the circle we have. So the first thing I'm going to do is I'm going to remember that v here is 20 degrees. All right. Down here, we know that's a right triangle, so that's 90. I'm going to use the triangle sum theorem to figure out what my y angle is. And so what I'm going to do is take 180 degrees, I'm going to subtract away 20, and I'm going to subtract away 90 so that I have that third angle remaining. If I do this, what's left is 70 degrees. And so I know that this angle here, y, is 70 degrees. And what that tells me then, and this is where I kept screwing up on this problem, I'm not going to lie, I've been kind of struggling with it. What I kept screwing up was I kept trying to use that inscribed angle to figure out that arc length, but I need to remember, and what we need to remember is that we need to use central angle to figure out arc length. And so really, I'm going to be using this angle right here to figure out what that arc length is. Now, if my inscribed angle is 70 and it creates this arc length here, that means my central angle needs to be 140 degrees. Because central angle is always twice the inscribed angle, or another way to think about it is your central angle is the same as your arc measure. And if this down here is 70 degrees, this up here is 140 degrees, which means the central angle that creates that arc length or arc measure would also be 140 degrees. And so that's a really big part. we're going to use that 140 degrees in a second because that's the portion of the circle that we want. But first we need to figure out what the circumference of this circle is, and then we're going to multiply it by the portion. And so circumference is always 2 times pi times radius. And if you remember from before I cleared my ink, we were saying, and we're using the same radius, and that is 4 let me check again. It was, sorry, I believe it was, I took 9.58, divided it by 2. So 9.58 divided by 2, yes, is 4.79 for a radius. And I'm going to use that to calculate my circumference. And so we have 2 times pi times 4.79. I'm going to write this as a decimal without pi. And so I do 2 times pi times 4.79. And I get after I round it, I get a circumference of 30.1. All right. Now what I'm going to do here to finish this problem up is I'm going to take that 30.01, the total circumference, and I'm going to multiply it by the portion that I want. And the portion that I want is 140 over 360. Because I'm using, and this is again where I kept screwing up, I'm using that central angle of 140, using the central angle of 140 here, and that's going to be the portion of the circle that I want. That's going to give me that red arc length. And so once I calculate this, I'll put it into my calculator to do it. I do 30.1 times, and then I put in parentheses 140 divided by 360, and what I get as an answer is 11.7 is my answer in centimeters, and that would be that length of my red arc right there. And so that is a pretty complex problem, a problem that I actually thought was less complicated when I put it on here, but we just need to find that inscribed angle. That inscribed angle tells me the central angle, so the inscribed angle of that arc measure tells me the central angle of that arc measure, and then I find the total circumference, and then I multiply that total circumference by the portion I want, which is the 140 central degree angle over the total 360, and that'll give me my answer of 11.7. All right, we'll go on to 4. And so 4, it's kind of working similar concepts. We have, first we need to find this arc measure BC here. We need to first find that arc measure BC, and that's not too bad to do. So the measure of BC, if the central angle, so the central angle here is 45 degrees, and it creates that arc measure BC, and I know, and like I said in the last problem, the central angle that creates the arc measure, those are the same length. So if that's 45 degrees, then the measure of arc BC also needs to be 45 degrees. So that's part 1 of this. Part 2 is just finding the measure of angle A. And the measure of angle A, well, that's going to be this inscribed angle down here. And so if the central angle, or I mean either way because they're the same, but if the central angle is 45 and if the arc measure up here is 45, then the inscribed angle is half of that. So I'm going to take that 45 degrees, divide it by 2, and I'm going to say that that measure of angle A is 22.5 degrees. All right, and then the last one, we need to find the length of AB. We need to find this length of AB. And what we have here is kind of like an isosceles triangle almost. This length and this length are the exact same. And so what we have is a circle has 360 degrees in it. So what we're going to do here is we're going to take 360. I'm going to go back to working in black writing here. We're going to take 360 degrees and we're going to subtract away the 45 degrees. All right? Subtracting away that 45 degrees is going to get rid of this arc measure right here. And so 360 minus 45 gives me, I believe, an answer of 315 degrees. Now, because these two sides here are equal, this green one and this green one that I just erased, these two are equal lengths. And so I'm going to split the remaining. So this 315 degrees needs to be split evenly to this portion right here and this portion right here. And by split evenly, I just mean it needs to be divided into 2 equal parts. And so I'm going to take 315 and I'm going to divide it by 2. And 315 divided by 2 gives me a length of 157.5. and that 157.5 is the length of that arc and is the length of that arc, or is that arc measure and this arc measure. And so that would be my answer for this problem, for the last part of this problem. So the measure of that arc AB is equal to 157.5 degrees. All right. Again, that one's a little tricky because we don't see that very often, but we saw with isosceles triangles every once in a while that we had that, we had 315 degrees remaining after we got rid of the 45 degrees, and that 315 just needed to be split evenly so it would fit this part here and this part here. I hope that brings some clarity to this question. If you have any more questions, please email me.